Let us try to understand how we can find the sample size for estimation of mean. From the central limit theorem, we know that the sampling distribution of means follows a normal distribution with mean mu and standard deviation sigma divided by under root n. So, what we know is the sampling distribution follows normal distribution where mean is mu, same as the population mean, and standard deviation or standard error is sigma divided by under root n. So, let us now see how we can get the sample size. We also know that z, which is x minus mu divided by sigma divided by under root n, this follows a standard normal distribution, right. Now, we can rearrange this equation. So, when you rearrange this equation, what we get is the n here, the n goes up. So, I can keep the n there, or I can for time being say that it is under root n when it goes up, and I can bring these values to the left side, right. So, what happens is your under root n will become z times sigma, the sigma will go up, divided by x minus mu. Now, remember this x is what we estimated and mu is the actual. So, this difference is kind of error in estimation. So, I can say in that equation x minus mu is either error or difference in the estimated value. So, I am going to take this difference as d. I can substitute that in the equation there. So, what I will get is your under root n is z times sigma divided by d. Now, left hand side we have under root n, which is a sample size. So, when I square both sides, left hand side I will have n, the right hand side it will become z times sigma square divided by d square. So, the denominator it is basically the error in prediction, and this is the population standard deviation. This is the critical value that we can take from standard normal distribution. So, what we do now is I want to find the sample size with certain confidence, right. Typically, we take the confidence as 95%, but nothing stops us from taking 99% or 90%. So, if I take confidence level as 95%, then your corresponding significance will be 1 minus of that. It is either 0.0, 0.05 or 5%. Now, what we can do is we can find under the standard normal distribution what is the critical value when alpha is 5%. So, let me explain how that is calculated. So, basically remember what we are interested in is finding the sample size with some amount of confidence, and I am taking the confidence level as 95%. So, if you look at the normal distribution, and if I assume that the confidence level is 5%, we typically divide the confidence level that we are taking or the significance that we are taking into two parts. So, if I take alpha as 5%, we'll divide that alpha. So, this will be alpha by 2, which will be 0.025, and the right hand side again the area is alpha by 2, that is 0.025. Now, I need to find the value of z for which the right hand side area is 0.025. Similarly, on the left side we are looking at the value of z for which the left hand side area is 0.025. Now, we can find this from Excel or any statistical table that we find at the end of statistics books. So, if you take alpha as 0.05 or alpha by 2 is 0.025, this value will get this as minus 1.96 approximately, and this is 1.96 or plus 1.96. So, all we have to do is substitute that z value. So, typically what we do is, instead of just writing z there, we can write the z as z alpha by 2. So, basically we are calculating the sample size with some confidence. So, I can replace that alpha, I can replace that z with z alpha by 2, and based on the significance I can substitute the value of that z alpha by 2 and I get the required sample size. The sample size for the estimation of population proportion we can get using the similar argument. So, in that case, when we have to estimate the sample size, when we are actually calculating the proportion, the sample size is z alpha by 2, which is basically the critical value, divided by d, which is the difference in the estimated value versus the actual value, square this, and we multiply this with the corresponding standard deviation, which is p estimate times 1 minus p estimate. So, this formula is used for calculating the sample size when we are estimating population proportion from a sample. And again, this z alpha by 2 is based on the significance that we are taking or the confidence level that we are taking. Let us look at an example. A hospital is interested in estimating the average time it takes to discharge a patient after clearance by the doctor. Calculate the sample size required to estimate the average time taken to discharge a patient at a confidence level of 95%. Assume that the error in estimation should be at most 5 minutes, that is, the d should be at most 5 minutes. Assume that the population standard deviation is 30 minutes. So, basically the value of d is 5. So, this is the maximum value, and we are assuming sigma, the standard deviation, is known and it is 30. And the value of alpha, we are taking that as 5%. So, that is 0.05, and for alpha 0.05, we just now saw that the critical value, that is z alpha by 2, will be 1.96. So, the z alpha by 2, the absolute value of z alpha by 2 will be 1.96. All I have to do is now substitute all these values in the equation that we just now saw. We will get the value of sample size. So, n is z alpha by 2 times sigma square divided by d square. So, this is 1.96 times 30 square, d is 5, which is the error. So, this is 5 square, and when you simplify you get this value as 138. So, basically if we are estimating the mean from a sample and we are saying that we need to have 95% confidence as well as the error in estimate should be at most 5, then we need a sample of size 138. That means we need 138 records to achieve the maximum error of 5 at 95% confidence.